Alrighty, in this video we're going to discuss information. It's a pretty big topic. I'm starting to realize just how hard this project is going to be. I watched the last video, realized that there were these stains on my sweatshirt that I was aware of, but I thought they'd be hidden, and they actually get accentuated. Well, I'm not going to remake the video, so I just turned my sweatshirt inside out because it bugged the hell out of me. My wife's going to kill me. Fortunately, she'll never watch any of this. This is kind of a first draft. I just want to figure out what are the nuts and bolts of trying to explain something. A lot of this, I think, it's frustrating because I feel like a lot of this is stuff that everybody should already know, or at least the people who are talking about things like the genetic code. They should know what information is before they start talking about the genetic code. Well, the people who made this paradigm clearly didn't know anything about information. Information is obviously a very important thing because, we live in an information society. These digital computers that we have built and now control our lives are based on information. So what is information? I like to keep everything simple. The last video, I had hundreds of things I wanted to say and I didn't say any of them. So I'll try and maybe weave some of those things into future videos. The basic idea about information is very simple. It's a matter of having and making choices. So the simplest one is a coin. You've got a choice between heads and tails. Well, you make that choice. It's heads. Okay, it's 50-50. It's one or the other. It's true or false. Is it heads? True, it's heads. So that's called a bit, one bit. It's a choice made from two choices. So then if we look at a cube, then boom. Well, that doesn't, all these faces of the cube are the same. I didn't generate any information. So then I roll that 2. Okay. There were 6 equal choices, and we picked 1 out of the 6. Okay. Well, that's an awkward, 6 is an awkward number. So let's do 8. Boom, 1. Okay, there were 8 possible choices, and we pick 1 of them. So 8 is 2 times 2 times 2. So 3 bits of information got generated when we rolled that 8-sided die. Now, the thing about information is, according to Claude Shannon, the way he described it, we can measure it, but it's based on probability. Okay, so if I have a rigged coin that always lands on heads, that coin generates no information. Okay. If I ask you a question like there's 2 apples, I say, which apple do you want? Apple A or apple B? Your choice of the apple generates 1 bit of information. But if one of the apples is rotten, and clearly rotten, and I know that and you know that, it's unlikely you're going to pick the apple that's rotten. I hope. So when you pick it, the probability of picking the good apple is so high, the information that's generated by that choice is smaller than if the equal probabilities. So what you got to know about information is not just sets of things and selecting from them. It's sets of things and the probability of selecting from them. So this is what information is. Shannon worked it out mathematically. He said it's identical to this thermodynamic definition. So let's call it the same thing. In thermodynamics, we call it entropy. And in information theory, we call it entropy. It gets into, obviously it gets more difficult than that, but it doesn't need to be. So in my mind, if you break it down like that, it's a 2-step process. Make a set, pick from the set. Make a set, pick from the set. So if you see it in those simple terms, then information is the same as selection, is the same as intelligence. Now, that's what I call symmetry. It's one thing is the same thing. So now that's where it requires some explanation. I don't think there's a lot of people out there going to agree with that. That's fine. We just need to agree that we're talking about information and we got to have definitions for it. So in in terms of the two-step process is make a set. Well, we'll make a set of this 1, 2, 3, 4, 5, 6. We made a set of 6. Then we said we're going to pick one. Boom. The act of picking it, selecting it, generates the information. So if it's perfectly symmetrical, there's no information. When I pick one of these faces, then I generate information. I break the symmetry. So I take a set of perfectly symmetrical things. Now I make them asymmetrical, or I make them broken by identifying one. Now there's this face. Now there's 4 faces that have a relationship to that face that I picked, and one face that has another relationship. And those relationships are now unique and identifiable, so they are information. So with a simple cube, you've got spatial information based on symmetry. Well, there's a lot of different symmetries in a cube. The one that's the most powerful in terms of math is the planes. So there's 3 planes, and they're symmetrical. Each plane is the same as every other plane, and that's true of the points, the vertices, the edges, the faces, the planes, and then you could start making sets of sets, and there's always this interrelationship. So we can easily then take a cube, and by virtue of breaking the various sets of symmetry and keeping our symmetry breaking symmetrical, we can create a code out of the cube. It's a cube language code. So this particular code is designed to play a game where I can put my finger on a point, I select it, and then and somebody else can call out another point. So I could say that black is true and white is false, and that we have red, green, and blue. So if I say true red, and then they say false red, I can do that math really quickly in my head because I know I'm going to traverse 3 edges, all 3, and any 3. So all I have to do to answer that question is red, green, blue. Or I could say green, red, blue. Or I could say blue, green, red. And so blue, green, red takes me from this point to this point. So I can then create all of these complex symmetries in a single set. They're each sets of sets. But by breaking symmetry, I start to generate information, and I start to generate codes. Well, that's how atoms work. That's how they make crystals. That's how they make life. So we got to understand symmetry and symmetry breaking and entropy. So what life is doing is it's generating this entropy through symmetry breaking. But its goal is not to reduce the entropy. It's to expand the entropy. So Erwin Schrödinger already said this 80 some years ago. He said that life is an aperiodic crystal that feeds on neg entropy. That's exactly right. You know, Karen Smith came along in 85. He wrote this book. You know, he describes, he's not quite up to speed on information theory, but his basic ideas are okay. Okay, so now we're looking at this big thing. So we know that what information is, and we know it involves selection. Well, how does it involve intelligence? Well, Darwin explained to us the process of natural selection. And that process is a purely mathematical process. And that process is what we use to generate intelligence. So Darwin used artificial selection. In other words, man-made breeding, breeding dogs, whatever. And he says that explains how natural selection works. He says, look, man can make selections, and it leads to evolution of dogs. And nature can make the same selections based on the criteria of the best choice, the fittest choice. So the choices that are made survive. So he's talking about sets making sets. This is a fractal. Okay, we'll talk about fractals later. It's a fractal algorithm. It's a purely mathematical idea. Natural selection is purely mathematical. It's the natural generation of information. Okay, well then, this is what intelligence is. So intelligence is easy, okay? I have a problem and I'm going to make a set of possible solutions. Well, the intelligent person is the one who picks the right solution. So it's the same as information generation. Which is the most probable choice? Which choice did you pick? Which is the right choice? Which choice works? Okay. So this is the same as the idea that we have many possible choices and it collapses to one choice, just like Schrodinger showed that a photon is a probability cloud. There's a probability of all of these possible places it can be. And we ask it a question. We say, where are you? And it answers us. It says, I'm right here. So it goes from a set of possible answers to a specific answer. So it collapses from many to one. That's what information is. It's a collapse of many possibilities, probabilities, to one specific one. Okay? So that's what selection is. That's what natural selection is. That's what intelligence is. That's how intelligence works. So there's a mathematical principle and there's a symmetry between these things that we call entropy, natural selection, and artificial intelligence. Artificial breeding, artificial selection, teaches us natural selection. Artificial intelligence teaches us natural intelligence. Man is practicing this art of artificial intelligence, but it's an emulation of what the universe does to create intelligence. So my brain obviously has an intelligence. My brain is not creating a simulation of the universe, okay? I'm looking out in the universe and I'm seeing things, and I'm then making a symmetry between my simulation of those things and what they really are, okay? What I believe is that this intelligence that I'm demonstrating is an emulation of the intelligence that the universe must have some kind of intelligence that when iterated for 15 billion years creates a simulation or an emulation of itself. So, you can make all kinds of, man is made in God's image. I agree with that statement. My interpretation of what God is the logic at the very smallest level and the logic at the very largest level. These are things that I will never know. I won't know what that smallest level is. I won't know what that largest level is. So the only way I can say a word to describe it is God. That's, never mind the fact that, we have a universe that's here and the alternative is to not have a universe that's here. So what's the difference between the existence of a universe and the non-existence? Well, hell, who knows that? I mean, anybody that thinks they know that, what created the universe? God created the universe. What is the logic at the smallest level? God. What's the pattern of all the things that are real in the universe? Well, it's God. These answers are easy if you realize that they're completely unknowable. It's not something that science is going to know. That's beyond the purview of science. I mean, each scientist has to use his imagination to invent that concept. So I'm not going to dither or grind over it. To me, it's pretty easy. God represents all knowable things. That my ability to know things is a tiny subset of that, and my actual knowledge is even a tinier subset than that. I mean, I'm struggling. I struggle to figure out my taxes. So who doesn't? Anyway, so in my opinion, you can't even to start to discuss the genetic code. I mean, what they've done is just dumb. So, they say that this code is 1-to-1. Well, right there, right out of the gate, you've destroyed the concept of information, because information is many to one, okay? So there's many molecules that could be a codon. And when they're translated, that's like observing a photon. So you take all possible codons, boom, you reduce it to one, CCC. Okay, I just reduced it to one codon. Well, there's many different nucleotides that could be in that. There's many different ways they could be arranged. It's not one codon. CCC is not one codon. It's one instantiation. It's one example of a codon. Then you come over here and you say the same thing about amino acids, but then they keep expanding it out. They say genes to proteins. Well, you're talking about an information-free information paradigm. You've eliminated all the information from your paradigm. Well, of course, it's simple and linear because you just defined it that way. But you're not saying anything useful. Everything you say is completely nonsensical and false because you've eliminated all the information from your code. So the actual table is not a deterministic graph. It's not a mathematical deterministic graph. You can't say this codon is this amino acid. What you have to say is with a degree of probability, this is probably CCC, and it probably at some future point in time and space will mean that there's proline there. So it's like a crystal ball. It's predicting proline. It's not dictating proline. It's saying that proline will probably be there. This is not a fixed linear matrix. This is a complex nonlinear probability matrix. This is a matrix of there's hundreds of molecular behaviors between the DNA and the amino acid, and we have to think about that in terms of the probability of the molecular behavior that's going to link. It's not a plug and socket. There's a probability that if we see this, we'll see this. So you have to start saying, what in the hell would create such a certainty out of such improbable events? But that's the whole point. That's the goal of the code. The code is trying to position atoms relative to other atoms. So if they're positioned like this in DNA, then they will be positioned like this in protein with a high degree of probability. Well, it can't do this in one byte, okay? It has to do it in layers. So what it's doing is it's reducing the entropy at each layer. At the very core layer where we have nucleotides and amino acids, that's where it wants the lowest uncertainty. It wants a high probability that the things will be what it wants to be because it's creating a mathematics with these probabilities, with this information, and it's multiplying them out to where you get these magical, impossible realities where DNA makes a protein. One cell makes a human being. No life on Earth makes all life on Earth. So now what we need to do is recognize, number one, this is not a static event that happens here and now. This is a very dynamic animation. That's what information is. It's an animation of logic. That's what computers do. They animate logic. So the universe is animating this information. It's purely spatial. It's unbelievably complex. It's totally nonlinear. There's nothing linear about this. The only thing linear about it is the delusion that you've created that it's linear. It's like in artificial intelligence, you get an image recognition program. So an image can be so many different things. It's just zeros and ones. You show this program something like 4 dogs playing poker. Well, there's many different possible images. There's many different, text sequences that would describe the image. So the intelligence takes many different images and then it selects from many possible descriptions. So you show it an image and it says 4 dogs playing poker. How did you do that? How did you know that? Well, it didn't. You can't program that into the algorithm. The algorithm has to learn, okay? It has to be trained. So that learning process creates these networks of logical connections. So the guy who wrote the program doesn't even know how it works. he knows how to wire these things together and then train them. So this is how robots learn. This is how we learn when we're little, and this is how life learns. So we can't assume that these fantastic abilities were given to life. We must assume that life had to learn them. So now we have to think about, how do we learn? Well, natural selection is a learning algorithm. That's what it does. It generates information through complex associations, and it builds up these associations. So it's a competitive environment where the things that work get kept and they go on to more rounds in the game, and the things that don't work get eliminated, never to be repeated again. And so it's a very competitive learning algorithm, and that's how artificial intelligence works, and that's how our own natural intelligence works, because it's an emulation of the mathematical principle that built it from the very ground up, from the geometry to the math and the logic, all the way up through the chain of causality, from molecules to cells to people to brains to societies. I mean, it's just a giant fractal algorithm. And you're never going to see that or understand it or be able to discuss it until you are able to define your terms. And the first term you need to define is information. They didn't even do that. They don't even know they're handed a flashlight and they can't find their ass with it. And so you just got to wonder, why are we even listening to this? This is idiotic. It's the worst possible paradigm. They've created this interrelated, nested sequence of nonsensical, logic-free statements, and it's so airtight that they say, well, there you have it, and it's been proven. No, it hasn't been proven, and no, I'm not going to go that route. Let's go a different route. So I think we need to, first of all, define our terms, and entropy is what information is. Now, entropy is a very difficult concept because there's so many different ways to use it and interpret it. And we're going to have to do that more later, but before we do that, we're going to have to invent some kind of math that can encapsulate these ideas of, if you think about it logically, what we're describing here, if we're describing information as this process of intelligence and learning, then we're describing a mathematics that learns. But worse than that, we're trying to describe a geometry that learns. A learning geometry. Boy, that's a big one. I can't wait to see me describe that. But we're going to give it a shot because we have to. And actually, at the end of the day, it's not nearly as hard as it sounds. So now that we've got our sweatshirt turned inside out in the right order, let's try and get our cause and effect turned inside out in the right order. Let's try and get our big boy pants on and get busy.